Hi, this is my brief take on the Gini index calculation based on an income distribution data that we have. The easiest approach to the Gini calculation is to visualize the Lorenz curve that's coming from the distribution data. And so what we have here is an example of an income distribution and corresponding Lorenz curve that we have drawn. Remember that the Lorenz curve is drawing the cumulative income share of various groups progressively with cumulative population share within the country. And in the table, we had calculated that for the cumulative population shares and the corresponding cumulative income shares. So these data points are what got plotted into the Lorenz curve. So the Gini index is looking at the gap that we see between the Lorenz curve and the line of perfect equality relative to the maximum gap that there could have been. The maximum gap that there could have been would be the gap between the line of perfect inequality versus the line of perfect equality. So think of this area of the whole area between the Lorenz curve and the line of perfect equality as area A, and think of the area beneath the Lorenz curve up until the line of perfect inequality as area B. Okay, so the area above the Lorenz curve until the line of perfect equality is A, and the area beneath the Lorenz curve until the line of perfect inequality is area B. Therefore, the Gini index could be written as the area of A divided by the area of A plus B. A plus B captures the maximum gap that there could be between a situation of extreme income distribution and the benchmark situation of perfect equality. And that maximum gap, the large triangle, is always the same. And that would be the area calculated as 1/2 multiplied by the base of this large triangle and the height of this large triangle, and that would be 5,000. So that's A plus B, the base. And so we can essentially replace the denominator by this fixed number, 5,000. So what really remains as a task for calculating the Gini index is the calculation of area A. Now, I like to calculate the area A directly using these area segments above the Lorenz curve, and so I'll call them area A1, A2, A3, A4, and A5, where A1 is capturing the area of a triangle, and then we have A2 capturing the area of a trapezoid. A3, A4 are also trapezoid areas, and A5 again is the area of a triangle over there. Because we have 5 quintile groupings, and because we assumed that the income shares are equal within each groupings, that's why we have these straight lines creating the segments that we have in the Lorenz curve, and the straight lines then give us the geometric shapes of a triangle or a trapezoid and so on and so forth. Now, if someone wanted to calculate this area by first calculating the area B and then subtracting area B from the full area 5,000, that would also be okay. So that would be a little bit indirect, but that's arithmetically equivalent. So let's calculate the areas A1, then A2, A3, A4, and A5, which would give us the full area A, and then that would give us our Gini index. So let's start with A1. A1, the area of this triangle, can be calculated using the typical triangle formulation, and we don't need a right-angled triangle to apply the triangle area formula. We just need a base and a height. So the base that we are looking at for the triangle is this length. So I'll go ahead and label that B1. So that's the base from this point to that point. And this is the tip of the triangle. And so the height of the triangle is this distance, the shortest distance between the base and the tip. And this distance in our construction of the Lorentz curve is 20, because that's how we built up the 5 groupings. And actually, if you look ahead, think of that as base 2, which would be part of the trapezoid calculation, base 3, and base 4. Then that would be the length of the base, and this would be the shortest distance between the two bases of the trapezoid. That would be the shortest distance between the two bases of this trapezoid. That's the shortest distance between these two bases of the trapezoid. And then this is the shortest distance between the base of this triangle and the tip. Okay, so A1 is going to be 1/2 multiplied by the base, and the base is here 20, which is coming from the diagonal line, so we know it's 20, 20, so the height is 20, and we know this from the income distribution data as well as the Lorentz curve drawing, that this is 4, the income share, cumulative income share. So it's 20 minus 4, that's the base, and the height is 20, and this will turn out to be 160. So let's go ahead and put that into the calculation. We have, remember, A1, A2, A3, A4, and A5. The denominator is 5,000. And we're looking for A1 plus A2 plus A3 plus A4 plus A5. So right now we already have the measurement of A1, and that's 160. Then let's proceed to A2. A2 areas of this trapezoid with these two bases and this height, the height being 20. So area A2, 1/2 times the sum of the two bases. One base is B1, that's 20 minus 4. The other base is B2, that's 40. 40 minus 14. Multiplied by the height of the trapezoid, that's 20. And this will turn out to be 16 plus 26 is 42. So 420. So that's area A2. We can go ahead and replace that. Proceed to area 3. 1/2 of the sum of the two bases. In other words, we are just taking the average of the two bases. B2 is 40 minus 14, and B3 is 60 minus this height, and that was the cumulative income share of 28. The whole thing is multiplied by the height of the trapezoid again, 20. So this is going to give us 580. Yep. So we can replace A3 with its number. And then we proceed to A4. A4 trapezoid with B3 and B4 as the two bases. So we'll take the average of those two bases. In other words, take half of the sum. So B3 is 60 minus 28. And B4 is 80 minus 52. The height of the trapezoid is 20. And this would give us 600. So now we have A4, that's 600. What's left is just A5. And A5, like A1, is the area of a triangle. And notice that for a triangle, we have a base, and the other base is the tip. And so, in fact, triangle calculation and trapezoid calculation are related in that in both cases we are taking the base and the other base, but in the case of a triangle the other base is always 0, so it just looks like it's half times only one base. It's really half times the sum of the two bases, but for the triangle the sum of the two bases is just the one base, since the other base is a 0 length point. In the case of trapezoids we have both bases being strictly positive. Back to calculation of area A5, it's just a triangle, so half times simply this base. And the length is what we just looked at a little while ago, 80 minus 52. And the height is this 20. And this would give us 280. Okay. Okay, well, we're almost there. Just arithmetic. This would add up to 2040, and we of course have the division by 5,000, and if you look at that as a decimal ratio, then this would be 0.408, or on a scale of 100, on a scale of 0 to 100, you would report this as 40.8. Remember that Gini index or Gini coefficient is reported either on a scale of 0 to 1, in which case this number would be 0.408, or it is reported on a scale of 0 to 100, in which case this Gini index would be reported as 40.8. A couple of thoughts. One is that here in this example we have just quintile shares, so we have 5 groups, and that's why we have 5 segments only, and we had to make the assumption that between these 2 points within this group, incomes are the same for everyone, and the same assumption for all the other groups. So then you see that it's a straight line, then straight line, and then straight line with some kinks. If we had more detailed information, so for instance, if we had 10 groups of 10% of the population in each group, so deciles, then we would have had a finer breakdown of the income distribution and a finer Lorenz curve. So the line segments would have been shorter and it would be more refined, and from a distance it would look more curvy. If we had even more detailed information, like if we had income information across the population more comprehensively, then the Lorenz curve would look really like a smooth curve even up close. So that's one thought. So the more income groups we work with, the more refined the Lorenz curve looks, and the more accurate the Gini index would be. So it is actually a good idea to know how to work with more groupings. The second thought is that the number we have here for this particular example, the 0.408 or 40.8, reflects a reasonably high degree of inequality. It's not terribly high because we do see in real life a number of countries that have much higher inequality than that, Gini index in the 50s or even some in the 60s. But we also have a lot of countries with Gini indices in the 30s, lower 30s, and also in the 20s. Just to give some perspective, United States used to have a Gini index income inequality that would be rated around here some years ago. Now it's actually gone up. It's probably in the neighborhood of 0.44, 0.45. But there you go. It's a Gini index, a quantification of the inequality that we see in the Lorenz curve or in the income distribution for a given economy.